Thank you, Achana. Thank you, everyone. This is so happy to join the OCP conference again. I joined the last several OCP conference, and during the conference, we share our contribution to OCP from 2OU to socket design, and also in the storage design, and Olympus design, and also in OpenBMC design, help the OCP to manage the rack. So why we so happy to work with open organization, why we share our design with our customer, and I think it is the key strategy of Inspur in the last several years. Because we were looking at the requirement of the customer in recent years. The customer size, the customer installation base is becoming bigger and bigger. They have a more common requirement for customization design. But it's kind of against the openness, against the open industry standard. When I began the server business with Inspur, we worked with Intel very closely. They taught us industry standard, open technology, commodity, building block, those kind of words. It means we must be open. We must follow the common standard. But recently, customer want to customization, want to unique design, want to do something they own that is different from their competitor. So that is what they're chasing. How we can address the differentiation and the unique design, customization design with the open standard. And I think this open is the key things. We open the platform infrastructure with our customer, and we have an open design base with customer, and we have an open standard for our modular design, the boundary between the module and the product platform. Then we are free to combination different kind of a modular design and into some specific customer side customization, the different design. So that is the model of JDM. We work with our big key customer. And also, we work very closely with open organization from ODCC, OCP, and OCP19. So through those open organization, we work with our customer, especially the second tier and the big industry, to share in a common design base. Through that common design base, customer can freely to organize their supply resource to make sure they can have a more free choice and also have the commodity cost, and at the same time can build up unique and the differentiation for their IT system. So based on those two concepts, work with the big customer using GDM model, and also work with the open organization to address the requirements of the public industry and big customers. And we address more and more the footprint in the server market. So one very interesting and very important product platform is SR Rack. It's a rack solution based on the ODCC standard. That is an open standard in China and very popular for the super secure data center like BAT in China. And we deploy thousands and thousands of this kind of rack in China data center, and some was delivered into US to support the BAT business in here. So based on that, we have many different kind of server nodes from standard requirement for memory intensive or storage intensive or code data or AI rack. So today I want to introduce this AI rack, which was very successful with one of our big customer, Baidu. It's deployed many racks of this AI rack. This AI rack have several very interesting points. First is polling. So this is the GPU polling system. We using 2 layers of PCIe switch to org 16 GPU in one for you box. Through PCIe cable, those 16 GPU can be distributed to multi-servers from 1 to 4. You can link all those 16 GPU to one server node, or you can split and partition those 16 GPU for 4 nodes. Based on that, it can create a very flexible hardware level polling technology for the training platform and the inference platform, which can be used in many different kind of scenario based on the requirements of their workload. Another polling technology based on the SR rack is our code data polling technology. So we're using SAS switch to org, hard disk driver pool with the computing nodes to make sure you can have many different kind of ratio from the CPU to hard disk driver, from tens to many tens. So that help the customer to balance between their requirements of the computing and the requirement of the hard disk driver capacity. So using this rack can giving customer a very flexible way to do that kind of a combination. So the ODCC rack is a very successful story. We work with ODCC. The ODCC is an open standard that is defined, and the rack solution have a unified management, unified cooling system, unified power system that giving power efficiency and the management flexibility and a very easy way to manage the system. And also the rack can be delivered in full rack. It's a full installed rack. You do not need a huge on-site engineer team to rack mount all those server nodes. It's already assembled, and it deliver as a whole to customer side. It just plug on your power and plug another several cables uplink of the Ethernet, then it's up and running. So we can deliver 1,000 rack in one day. So that is a huge step for the efficiency of deployment in a data center. So today we come in here, say we want to share, we want to contribute more design to the OCP. The first we want to share with the community is the 2U 4-socket design. This design is contributed by Inspur and Intel together. Intel talk yesterday already introduced something around this one. That is the 2U 4-socket high-density computing design that can giving more power efficiency. You can save more power and have a more computing intensity in one rack, density in one rack. So I think that is the first Cascade Lake 4-socket OCP design, and we already signed the papers. It will be shared through the OCP platform very quickly, and you can download and replicate replicate this design. So we was taught in the future 70% of the internet workloads will be run by 4-socket platform because of if we can put the 4-socket in a 2U compared to two socket 2U. First of all, is saving space. Secondly, it also can saving power. The power saving one thing is from the fans, and also because we have a more concentrated platform, we will have a more high efficient of the power convert for the onboard DC to DC. Compare to two socket to 2U versus 2U4 socket, you will have double number of the CPU in one rack, and at the same time you save the management NIC port from the switch to the server side to saving cost for management, and at the same time you're saving half size of the fans, and also you only need half number of the chipset to manage the system. So that is the one is the cost saving for the motherboard, and also is space saving, and third is also saving energy. So we thought this 2U4 socket cascade lake design can giving us more efficient in our data center, and also because 4 socket can give you more memory capacity in one node, that probably help a lot of heavy working loads be working more efficiently, because in recent days we see the application in superscale data center becoming more computing intensive, memory intensive, and IO intensive, especially for AI working load. So when we're talking about the AI workload, we will contribute another design that is a JBOG design. This JBOG design, compared to the design we see in recent days, it have several things is different. The first of all, it using a 2-layer switch fabric. So one layer is for the span, another layer is for the concentration. So this 2-layer design can provide several different kind of topology to link to the server. First of all, 2-layer give you enough bandwidth, PCIe bandwidth to the server node. For each server node linked to the JBOG, you can have 16x individual 16x interfacing, and also you also can link double PCIe by 16 to one server to gain more I/O bandwidth to feeding the GPU with the data. And also the topology have a two way you can configure. In one configure, you can link your server directly to the second layer. That gives you in a more less one hop to the GPU, and also you can link multi-server through the 2-layer PCIe switch. It's mean that is in a multi-host mode to configure the PCIe switch, and then you can share all those 8 GPU across one or two systems. So this JBOG is a XM2 design. It's mean all the GPU is linked together through the NVLink. We doesn't draw in this picture, and also because we have a 2-layer of a PCIe switch and a multi working mode and the topology to link to the computing nodes. So it's a very flexible design. And also in this JBOG, you can put all the GPU inside the box, and also it have NVMe along with the GPU. So that is in a storage and GPU box at the same time. So this design will be contributed to OCP very quickly. I think it will be open in next quarter. Uh, I want to emphasize another very interesting solution which based on the Olympus design we already contributed to OCP is this 16 to 32 GPU solution based on the contribution from Inspur of four-socket Olympus design. This four-socket Olympus design, have a four-socket CPU, have enough memory, and they have enough PCIe LAN to driven the GPU through the PCIe cable. And so we using this four-socket design, Olympus design, so the PCIe can be connected to the 16 GPU box. The 16 GPU box is based on the NVIDIA technology, and we're looking at the topology on the screen. You can see through those four CPU, each GPU have a two link. You can down to the GPU box. In each GPU box, you can have a 16 GPU. So combine those two together, that is a 32 GPU. So I think that is the first solution you can find in OCP, which can provide a 32 GPU solution for your training platform or your inference platform. And you can see from each CPU to the GPU box, you have enough PCIe lanes to make sure you can feed in those GPU, efficiently. And also, all the GPU boxes is based on the latest technology of NVIDIA. You will see this design in our booth. You can see all the GPU is NVLink based GPU. It's based on the we call AF 5888 design. So please feel free to go to our booth and see all those design, in real, in physical, and you can touch it and you can open it, and you can see the four-socket 2U cascade, first OCP cascade, and you can see the JBOG. And also the JBOG is with GPU and NVLink, the two-layer PCI switch, and also with NVMe drivers on that. And you can see this 32 Olympus-based solution for a huge GPU pool. So I want to say open together is a very important it's a very important one for OCP, and also it's the spirit of Inspur. We want to share our key design with our customer, and we also want to, through OCP, through open organization, to open our hardware design to provide the design base for the innovation of the hardware platform. In the future, we thought the customization design and the innovation will be extended from software side, from the open source software to the hardware side is in an open source hardware design. So we were working with open hardware organization like OCP more tightly to contribute our design with the community. So one thing is very important is the OCP OEM. That is an an open standard for accelerator module or daughter card. That will be in a project between OCP and the Inspur together to define that module and to share some of our design to help, to integrate the new accelerated design with the computing platform. And another thing is we now work with the spec organization together to define the machine learning specification, the benchmark spec for it. So Thank you very much for your attention. Please feel free to go to our booth to see all the 3 contributions we will contribute to OCP organization. Thank you very much.